So in 13.7, we're going to do area again, but this time it's for three-dimensional objects. It's not going to be what's inside the three-dimensional object. It's going to be what's around the outside, the surface of the three-dimensional object. And so we call this surface area. All right, so here's some areas. There's a white rectangle, a yellow rectangle, and a green rectangle. We're going to find the area of each one. So 6 times 5, obviously, here. 6 times 15, I apologize. And so 15 times 6 is 90. So each of those are 90 square inches. And 2 times 15, right, is 30 square inches. And 2 times 6 is 12 square inches. So that's the area of each of these. Now, to find the total area of this thing, it seems like there's 2 white rectangles. They're both 90s. There's 2 yellows that are both 30s. And there are 2 greens that are both worth 12. So we're just going to add those up, right? 90 plus 90 plus 30 plus 30 plus 12 plus 12. There are 6 rectangles here. And when you add those up, you get 4. And then nicely, 9 plus 1 is 10, plus 9 plus 1 is 10, 20, plus 3 more is 26. This is 264 square inches. Now, what is this odd shape? Well, it turns out, if you take a box, let me draw a little box for you, like that, okay? You draw a box, all right? The front and the back of that will be the same exact rectangle in white, okay? The sides, right, there's a green side there, say, and there's another one we can't see on the other side. And the top would be the, oh, I actually did this wrong because the yellow would be the front. My fault. The yellow would be the front because this little extra flap here would be the top. Okay, and so the white would be the top. And so those are the 6 sides of an unfolded box, also known as a rectangular prism. Okay. So say you want to know how much gift wrap you need to wrap a gift, right? The gift wrap wraps around the outside area of the box, and that's called the surface area. All right, so what you saw there was called a net. A net is a 2-dimensional representation that can be folded to make the 3-dimensional object. So there's the box. You saw the answer to this in the warm-up. So let's see this. I like to start with the bottom of the box. So I'm going to make this one, well, make it in white since I made the other one in white, didn't I? All right, so we're going to make the bottom in white. So now notice everything's angled here, but in reality, right, it's a rectangle. The bottom of most boxes is a rectangle. And then folding down from the sides, and notice I put dashed lines to the edges. Those are edges, those black lines that you can't see. Folding down from the sides, right, if you cut it, there would be these green flaps down here. All right, oops, and they should be exactly the same size. Otherwise, if they're not the same exact size, the box would be all crookedy. Okay. Now, there's also, in the front of the box, right, in the front of the box, there's this rectangle. Oops, I'm going to do this. And when you draw this, where I'm pointing right now, those should be the same length. So when you fold it, it matches up. Okay. And then there's a back that's exactly the same size, right? And then last but not least, there's a top to this box, right? And the top is exactly the same size as the bottom. So notice there's 6 rectangles. Now, so you're going to find the area of all 6 rectangles and add them up. I've just taught you how to do your homework. Now, the key is, one of the shortcuts is, the top and bottom are going to be the same size every time. These 2 green sides are going to be the same size every time, okay? And so on. All right, so let's try drawing this. So a box is a prism, all right, a 3-dimensional box is called a prism, and if it's made out of rectangles, it's called a rectangular prism. So if you've got triangles, and this is not all triangles, but if a triangular prism is a mix of triangles and rectangles, but if it's got triangles in it, it's going to be a triangular prism. Now, a triangular prism is not the same as, say, a pyramid, which has a point at the top. A pyramid has a point at the top. This is not that. This is called a triangular prism. So now think about looking down from the sky at that. And I'm going to turn it. And if you look down from the sky, you still have the same rectangle at the bottom you had in the last time. What's different this time, right? These, if you fold those triangles down, you have these at either of the short ends there, right? And they should be the same size. And what about these sides here? There's two of those. Those are rectangles if you look at them, right? If you looked at them from the side, they're rectangles. And, you know, I made it too big. And the reason I made it too big, all right, so let me just do this. This and this, right, should be the same exact length if I'm doing it perfectly, because they have to fold up. And I'm going to put this here. All right, now notice there are only 5 sides to a triangular prism. Now the 2 red ones are going to be the same size. The 2 green ones are going to be the same size, otherwise it would be all crookedy. And the bottom is different than the 2 reds. The 3 rectangles, the 2 red rectangles have to be the same size for it all to work, but the bottom could be anything. All right, and so, but there will be 5 areas to add up there. All right, so we're going to find the surface area of our first one. So to be, they're all somewhat long, but just be methodical. So let's start with the bottom. The bottom is 10 by 4. That means the top is also 10 by 4. And then, which are both 40 square inches. And then let's do the front. And the front, right, is 6 by 10. It doesn't matter which you put first, but that's 60. And that means the back, in the back there, is a rectangle exactly the same size. So that's also 6 by 10, 60. And then you have the sides here. Now, if this is 4 on the bottom, this side has to be the same as this, right? If you have this side taller than this side, the box would look all wanky, right? So that is 6 by 4, and there are 2 of those, and that's the way it's going to work for a rectangular prism. And so you add all those 6 sides up, you get 8, and 10, 20, 24, and this is 248. Still square inches, right? It's the surface area of the total surface. If you unfold that, say you made that box out of cardboard, you would need 248 square inches of cardboard. A cube, all the edges have the same length, and all the sides have the same area. So let's look at this. So it's still got 6 sides. So it still has a bottom, which is 4 by 4. Right, which is 16, and a top, which is 4 by 4, which is 16, right? And then it has this side over here, which is 4 by 4, which is 16, and the opposite side, which I shaded, 4 by 4 equals 16. And then you have a front and a back, which is 4 by 4, it's 16, and 4 by 4, which is 16. Now, duh, it's 16 times 6, okay? Now, you absolutely can do 16 times 6. I just warn you. On the test, for whatever reason, everyone gets the rectangular prism correct, and then they mess up the cube. 16 times 6 is 36, right? 6 and then 6, it's 96 square centimeters. You add all that up. 6 sides on all cubes and rectangular prisms. When you roll a die, right? When you roll a die, there are 6 numbers on it, right? And I don't know how it goes here, but let's say it's this. Okay, like that. There are 6 sides. Oh, I said draw a net for it. I went right to the next question. This is because I knew. All right, so let's do the net. So the net, went to the surface area first. Sorry, the net for this, I like to draw the bottom. So it's all squares, right? They're all going to be the same size. So you have a bottom, and then you have, right? You want to draw squares every time. Ugh. Firing myself as an artist. Okay, there we go. All squares, all squares. And still looks very rectangular, right? And then you can stick by the way, you can stick the top on any of the ends. All right, so gift wrap, right? So now you have to keep track of everything. It's not so easy because it's over, right? But let's start with this side right there. That side is 8 by 2, but I don't want to do the problem in the yellow. So that side is 8 by 10. Now that means in the back side there must be another 8 by 10, right? So these are 80 square inches. You don't need the units for this. All right, now then over here, that side is 9, and if that side is 8, you know, this artist made his drawing a little more artistic, let's say, than mine. If that side height there is 8, this height is 8, so we have a 9 by 8, which is 72, and there's one in the back that must be the same. All right, that's 72. So what's left? Well, the top. All right, so the top is, all right, what is the top? Well, it's 9, or the bottom is the same, 9 by 10. Here's a little shortcut for these problems. There were 3 numbers in this problem, right? 8, 9, and 10. Did we multiply every possible combination of 8, 9, and 10? Yes, that's what happens. You do 8 times 10, 8 times 9, 9 times 10, twice, right? Because there are always 6 sides in a rectangular prism. You add those all up, so you get a 4 here, and then you have 8 plus 8 is 16, plus 7 plus 7 is 14, which is 30, and then 9 plus 9 is 18. I'm getting 484 square inches of gift wrap. Now, if you go to the store and buy gift wrap, right, sometimes it comes in a tube sort of thing, right? And there will be a label right about here, and we'll say how many square inches, square feet, square centimeters, square meters, depending, is in the roll. And they're not all the same. I warn you about that. They also have sort of folded gift wrap that comes in squares. Still, it'll say the square, the area of gift wrap that is in there. All right, so finally, this is a pyramid. What makes the right, let me just make sure you understand the difference. A triangular prism, right, doesn't have a point at the top. A pyramid does. So let's draw a neck for this pyramid. So I like to start with the bottom. Now this pyramid is a square pyramid. It says that. Not all of them are. The classic pyramid that you think of in Egypt is a square pyramid, but you could have other shapes at the bottom. You have a rectangle, you could have a triangle, but this, and try to make it more like a square. Now what's the sides? The sides are all triangles. It looks like that. Approximately how much cardboard is required to make the box? All right, so I told you that every combination gets multiplied. So it's 3 times 2 twice. It's 3 times 3 twice. And since there's 2 3s, there's another 3 times 2 twice. That's what happens. You want to figure this one's through by 2, and then the back, right? This one over here is 3 by 2, and then the back, and so on. So this is 6, 6, 9, and 9, and 6, and 6. And so 6 times 4 is 24, and 24 plus 18, 9 times 2 is, so there's 42 square feet of cardboard there. All right, so each of the 6 sides is 8 by 8, 64. Right, now I'm going to write it out the long way, and I used to not do this, and then I get wrong answers, but it is 64 times 6 sides. So it's 24, 384 square inches. All right, so Steffi wants to paint the cube below to make a table for her room. This was the thing when I was in college. She isn't going to paint the bottom, though, because no one's going to see it. So how much surface area will she have to paint? Well, each side is 3 by 3, 9 square feet. But she's only going to do 5 of the 6 sides. So she only needs to paint 45 square feet, right? Because she's not painting the bottom. Good luck with the homework.